For number 2, we want to find the surface area of the surface generated by revolving a parabola about the y-axis. So the fact that this is right, we have a formula for surface area, but it's for parametric curves. Luckily, this is a pretty easy curve to parameterize. We could just let x equal t, y equal t squared. Right, that would certainly give us that parabola. And since we want to go from 1, 1 to 2, 4, well, that means that x is going from 0 to 1, or I'm sorry, from 1 to 2. So that means t is going from 1 to 2. Okay, so that is parameterizing it. And then we also need to remember that the surface area formula, it's going to end up being, it's going to be the integral from 1 to 2. And since we are going about the y-axis, it's going to be 2 pi x times the square root of dx dt squared plus dy dt squared. Okay, if it's about the y-axis, there's an x. If it's about the x-axis, there's a y. Right? That's the only difference in the formula. Okay. Let's see. I mean, usually I break this up into 3 steps, but I think x and y are simple enough. We can just do it all at once here. Let's pull the 2 pi out. We'll do an integral from 1 to 2. The blue x there, well, x is t. And then under the square root, dx dt is 1, so 1 squared. And then dy dt, dy dt, this would be 2t here. And 2t squared would actually be, 2t times 2t, that's 4t squared. Alright, so that's the integral we got to do. How are we going to do it? Well, this one's actually pretty doable by hand. You could do a u substitution, right? You could let u be the thing under the square root. Du would be 8t dt. So t dt would be 1/8 du, which works out perfect because there's your t dt. Those two together will become 1/8 du. So this is going to work out perfect. This is going to be, so you got a 2 pi. You're going to have a square root of u in there. And then you're going to have a 1/8 du for the green stuff there. And we might as well change the limits too. The limits were 1 and 2. If t was 1, u would be 5. And if t was 2, let's see, 2 squared is 4, 4 times 4 is 16, plus 1 is 17. So those would be the new limits. That way we don't have to switch back to t. Okay. 2 pi times 1/8, that would be pi over 4. This is u to the 1/2 power. The integral of u to the 1/2 power would be 2/3 u to the 3/2 power. And that'd be evaluated from 5 to 17. So let's see here. Let's see, you got a factor of 2 that cancels, so it's going to be pi over 6. And then you're going to have 17 to the 3/2 minus 5 to the 3/2. Which you could just leave it like that. Another common way to write the 3/2 power, that's like 1.5. So another common way to write the 3/2 power is like this, right? That would be, that's the first power, that's the half power. Multiply them together, you get the 1.5 power. Same thing there. So that would be the exact surface area of that surface.